purpose.
What's up, guys? Tom from trèSci here in the path of totality, and it looks like the moon has just started to come across from the top right. You can see a little sliver of the sun being blocked. We are very excited for the totality to come. Awesome.
What's up, you guys? Welcome to trèSci Weekly episode 29. I'm one of your hosts, Jonathan Ullman, alongside first premiere on cam, Mr. Kyle Kalita.
How's it going?
Good. Thank you for joining me today.
Thanks for having me.
My pleasure.
Subbing in for Tom, but
yeah,
big shoes to fill. But
so some of you guys may have noticed no Tom this week. Actually, there was really not a lot of science news. Nothing really notable happened this week, so we figured Kyle and I would just talk about motorcycles for an hour.
Cars, motorcycles, small boat engines, whatever you want to talk about.
Exactly. No, actually, Tom is down in Tennessee, where him and Chrissy, his girlfriend, went to check out the total solar eclipse. And we expect to hear from him a little bit further into the show this evening. So
Awesome.
we'll try to get him on the horn. But yeah, Kyle, we spent the large part of this afternoon over at the Patrick Mitford Carnegie Teen Library.
Oh yeah.
And what did you think, man? What was your impression of the solar eclipse, the partial solar eclipse from our perspective, and just maybe the event in general?
The event in general was a massive turnout, way bigger of a turnout than I thought.
Yeah.
So really the whole community and all the families and the kids came out, and everyone was looking to have a good time and learn. So it was a really good time. The eclipse itself was really cool. I've never seen something quite like that. With not the naked eye, but with just a small pair of glasses in front of your eyes. So it was cool to see in person rather than just a video of or something like that.
Definitely.
So, yeah, overall a great day, really great day.
Yeah, I agree. So thank you guys down there at Patrick Mitford Carnegie Library for having us and allowing us to basically talk a whole bunch of nerdy stuff with people who might not otherwise care. Yes, it was cool. I was happy that all the equipment that I brought along actually worked, because I didn't really get a chance to set it all up together until the day of. But it all seemed to go pretty flawlessly there.
Huge hit, yeah.
So yeah, I think everybody was pretty happy about it.
Yeah, definitely. Especially having the monitor displayed with the what was that? Just a viewfinder with the camera hooked up to
Yeah, so it's basically a finder scope for a larger telescope that I have hooked up to a CCD camera. Ran that through this laptop through a program called SharpCap, which specializes in astronomy photography.
Okay.
And then just HDMI out into a larger monitor so that people that didn't get a chance to get eclipse glasses were able to watch the same thing that we were watching, essentially.
Yeah, so, that was awesome.
Yeah.
So everyone in line was still watching something.
Yeah. So if you guys were there and you're joining us now for the first time, thank you for checking out trèSci Weekly. Of course, we were talking quite a bit about our YouTube show that we do here. If you're just joining us for the first time, this is our weekly video podcast, typically about science news and trending science topics on social media platforms like Facebook and Twitter and things like that. We like to try to break it down at the kind of not the high science level, but a scientific level that lots of you guys can hopefully understand rather than the really, really intricate details.
Yeah.
Although we do like to say kind of technical as well.
Totally.
You can subscribe to our YouTube channel. That way you get the email notification every time we go live on Monday night. If you haven't done so already, that is a huge help for us in terms of growing the channel. You can also like our page on Facebook.com/trèSci Weekly and follow us on Twitter.com/trèSci Weekly in order to stay involved with the community throughout the week. And if you're feeling extra generous, you can go over to Patreon.com/trèSci Weekly, where we have a subscription-based service. If you would like to financially back us there, we would really appreciate the help. But of course, don't feel pressured. The videos always go up for free anyway, so no big deal there. So Kyle, the first thing I think we should do is check in with our good friend Tom, who basically said we can give him a call, and I want to hear straight from the horse's mouth exactly how the totality went. So let's see if we can get Tom on the line here. I'm just going to call him up, see if this works. So, of course, you got Tom on speed dial. Put him on speaker.
Hello.
What's up, Tommy? How we doing? You're on trèSci Weekly.
How we doing?
I'm pretty good, man. How about yourself?
Doing good. We are just in our hotel room over in Tennessee, relaxing.
Nice, nice. So tell us a little bit about what you guys experienced down there in Tennessee. How was the totality?
Yeah, so we were at a big event in Gallatin, Tennessee. There was tons of people there gathered to see the totality. So we actually got there at about 8 in the morning because we heard stories that there might be tons of traffic. Turns out there was no traffic, so we chilled for about 6 hours.
That's awesome.
So when it finally came time, we went all the way up on this big grass hill, and we put our chairs out and got ready to see it. And what we saw for the first part was what you guys saw, just the moon coming in to eclipse the sun. But why we came all the way down here to Tennessee that we saw is as the sliver gets smaller and smaller and smaller, it's like somebody put the moon perfectly in front of the sun, just split it right in there, and then you get this black void of a circle, and you see these beautiful yellowish hue of the sun's atmosphere, and you can see some stars poking out. And I say it dropped about 10 degrees, which was nice, because, you know me, I was nice and sweaty in Tennessee.
Wow,
so
yeah.
The lower temperature was great, and just totality itself was something else.
Oh.
I'd never seen anything like that, obviously, and it was just something I was glad to be a part of. It's really cool.
Awesome, man.
And
Yeah.
then one other thing that stuck out to me was when it started to come back, the sun, that first little sliver of light, the diamond ring, because we were looking at the totality without eclipse glasses because you can't, because there's no sunlight. So we saw that diamond ring effect when the sunlight first started to come back on, and it was just amazing how that small point of light could be so bright, and you instantly had to turn away and get your eclipse glasses back on.
Yeah, incredible, man. So
Good stuff.
how long did the totality last for you guys?
Yeah, so it was just about 2.5 minutes. So 1,000 miles of traveling, waiting all day, 2.5 minutes. But it was pretty awesome still.
Right on.
It must be, yeah.
And so were there festivities where you guys were? Was it like a party scene, or was it mostly kind of quiet, laid back, and everybody kind of was able to chill?
Yeah, so there was a stage, and they were playing music and stuff, and it was like kind of a mini event, but when the eclipse started, all that stuff kind of died down, and it was just people relaxing, checking out the eclipse.
Very nice. Very cool. Well, what would you say
Yeah,
overall? Would you?
One last thing before you guys head out.
Yeah, sure.
It was really cool because the field we were on was so massive that in the beginning of the field, we heard them start cheering and yelling because they saw the totality very shortly before us, and then a wave of sound came across the crowd.
That's
Everybody
so
started
cool.
going "Oh man!" So it was pretty cool.
That is so cool.
Yeah.
Awesome, dude.
Once in a lifetime.
Yeah. So what do you think? Was it worth the trip down?
For me, yeah, it definitely was. But I could see how some people traveling across the entire country might feel like it wasn't worth it, but I really thought it was amazing.
Awesome.
Yeah, it was pretty awesome.
Excellent, dude. Well, thank you so much for chiming in and allowing some of your vacation time to still be dedicated towards trèSci Weekly. We really appreciate it, dude.
Of course, man. trèSci is life.
All right, brother. We'll let you get back and enjoy the rest of your trip. Safe travels back home, and we'll see you for next week's episode.
Sounds good. I'll be in the chat under Chrissy, the alias.
All right.
All right.
Perfect, dude. Catch you later.
Take care, guys.
Later, man.
So there you have it, dude. So it looks like we should have all probably went
Probably.
down to totality.
It sounded pretty cool.
Yeah, but that's okay because, as we'll see, I'm going to close the show with the map for the next total solar eclipse, Path of Totality, that will be in April of 2024. So we'll see that.
All right, so still some hope.
There's still some hope, right?
All right.
Hopefully I don't die before that happens.
Just take it easy cleaning pools.
Exactly. So Kyle, I want to kind of dedicate this episode towards the eclipse, obviously, but instead of going through the weekly news as we normally do, my thought was to highlight some of the upcoming research publications that we can expect to see, because there were some really interesting projects that took place during the total solar eclipse. So I have five little stories that we're going to talk about, five basically things that I'm excited to see the science come out from.
Okay.
And we'll just go through them. There's a bunch of pictures, a bunch of videos that you and I can digest and share with the audience, and then we'll kind of talk about how we feel about them.
Cool.
Before we do that, I just want to bring up two images, because a lot of what we're going to be talking about has to do with the anatomy of the sun, if you will. So the first image I want to show is just a diagram of the different sun layers, or the different kind of parts of the sun that we have identified as, being somewhat different. So we've got basically the inner core of the sun. That's where nuclear reactions take place. That's where the light and the heat is basically produced, because the pressure and temperature is so high at the core of the sun. Nuclear fusion can take place. Moving outward from there, we have a radiative zone where the light transfers from atom to atom by way of radiative transfer. So basically the light kind of just spits out from particle to particle and goes in this kind of crazy path until it eventually makes its way to a convective zone. That is where large swaths of particles actually move together in big convection currents.
Okay.
And then finally, they will reach the photosphere, and the photosphere is that layer of the sun that we typically see if we were to look at the sun. Right? So that's the outer layer, the photosphere.
Okay.
Just beyond the photosphere, there's something called the chromosphere, which we don't know a whole heck of a lot about because it is obscured by the intense brightness of the photosphere. And then just beyond the chromosphere is something called the corona, much like the beer Corona, which I'm sure you and I have partaken in. We may have had one of those. The corona is this kind of wispy atmosphere-like layer to the sun that you can only really see with the naked eye, or instruments for that matter, during a total solar eclipse. So a lot of what we're going to be talking about is going to be studies dedicated towards understanding more about the corona of the sun, because it's actually what we know the least about, believe it or not.
Cool.
So, one more image just to show you what I'm talking about. This corona eclipse image here, Kyle. Yeah, this guy here. So that's what I'm talking about when I mentioned the corona. This is a picture taken by Miloslav Druckmüller during the total solar eclipse in Indonesia on September 3rd of last year. So this is a really spectacular image. You can see a lot of the finer details of what I call this wispiness of the corona, and that's kind of what most scientists that are interested in doing research during the eclipse are taking a look at. So, without further ado, let's jump right on into the stories here. So number 1, Kyle. The Hinode spacecraft, a jointly owned and operated satellite between NASA and JAXA, which is basically the Japanese equivalent of NASA in Japan, will have used its X-ray telescope, or XRT for short, to view the solar eclipse from space. According to NASA, quote, "The XRT instrument is optimal for viewing the hot corona, and these images can provide context images for ground-based eclipse observations. Eclipse scientists correlate the two sets of observations to determine where the emissions seen from the ground originate from on the sun itself. One study will look at X-ray jets, that is, explosions that erupt from the sun's surface, expelling hot gas into the corona, on the limb to determine where they occur more commonly. This research is best accomplished with the view of the lower corona that can be seen only during a total solar eclipse." End quote. So, we've got a couple videos here to check out. Let me bring them up as well. The first one is, actually they're both courtesy of NASA's Marshall Space Center YouTube channel. The first one is Hinode, this same spacecraft, looking at a solar eclipse on March 10th of last year. So we'll kind of just see probably an analog as to what the spacecraft saw during this total solar eclipse today.
Sweet.
And then the second video will be kind of like a highlight reel of some of Hinode's accomplishments in solar science up to this point.
Cool.
So let's take a look.
Sure.
I'll give you one of the earbuds,
Oh, definitely.
one of the airbuds. You ever watch that movie?
I have not.
It's a gem. It's a classic.
All
And when you're ready, on your mark.
Get set. We'll rock it over.
Okay. So that is some sped up footage of what the Hinode spacecraft probably saw, similar to today's total solar eclipse. And you can see in the X-ray light, most of the sun actually looks dark, except for the really, really hot areas on the surface there. That's going to be highlighted in X-ray light that camera is sensitive to.
Gotcha.
So we've got that one. And then if we want to jump to the next video here. So, as you can see, I'm excited for pretty good reason, right? I know it has unveiled a lot of the sun's inner workings for us over the past 10 years. And so, taking a look for these X-ray jets, right, at the limb of the sun, in order to see if that's where the corona gets a lot of its heat deposited into it. Seems like a pretty interesting study.
Yeah,
So
absolutely.
yeah, so I'll be anticipating the results from that one. Let's see, we got some traffic in the chat here. Karen Riley says amazing video. Nancy Kalita says yeah, great vid. So I'm glad you guys enjoyed that. Awesome. Kyle, should we continue?
I say we do.
I say we do.
I say we do.
I say we do. All right. So this next one is about a moon orbiting spacecraft that we have.
Okay.
So number 2, Kyle.
Cool.
NASA's Lunar Reconnaissance Orbiter, or LRO for short, will have pointed its camera toward the Earth during the solar eclipse in order to compare the shape of the moon's shadow, or the umbra as it's referred to a highly accurate computer model as it travels across different elevations throughout the United States. Right? So I thought this was just clever because we see the solar eclipse from our perspective. It looks beautiful and it's amazing, but there are cameras that are orbiting other bodies of, the moon Earth system that can just point their cameras back towards the Earth and see something entirely different.
Yeah.
Right?
Totally.
So we've got another video to share with you.
All right. Thank you, good sir.
You're quite welcome. All right, so this one comes by way of NASA Goddard. So huge shout out to them for putting this together.
What we're talking about is several visualizations of the path of the moon's shadow during the eclipse in 2017. Everything in it is driven by the data. So the color of the ground, the position of the path of totality, the lighting from the sun angle, all of those are things that are based on data. A lot of NASA products were used to create this visualization. I used the Lunar Reconnaissance Orbiter, the laser altimetry data from that, which gives us a digital map of the elevations on the moon. For the Earth, I used something called SRTM. This was a radar that was flown on the space shuttle. For the positions of the Earth, the moon, and the sun, I used a JPL ephemeris. An ephemeris is just a list of positions, but it's the most accurate tabulation of those positions. This visualization is unique because it shows the effect of both the irregular edge of the moon, the limb of the moon we call it, and the elevation of the observer. Now, we've known for a long time that the elevation of the observer affects where the shadow is. And we've also known that the mountains and the valleys along the edge of the moon affect the shadow. So you may have seen on eclipse maps in the past that the image of the umbra, that shape of the shadow on the Earth, is drawn as a smooth oval. But we know that the moon isn't smooth. Around the edge of the moon, we have these sort of jagged peaks and valleys. And a peak can block the sun a little bit earlier than you thought, and a valley can let the sun in a few seconds longer than you thought. The combined effect of these peaks and valleys is to create a shape that's not really an oval, it's more like a polygon. But it hasn't actually been seen in exactly this way before, where we calculate those circumstances for every point on the map and draw that shape. Totality is that 2 minutes when or 2.5 minutes when the moon completely covers the sun. The sudden darkness of totality is just something that a lot of people can't compare to anything else. I love the idea that I'm giving this kind of map to other people, and especially that it's more detailed and more accurate so that people are actually in the right place to see it.
Kyle, what are your thoughts on that project, that video there?
Sounds like a lot of work.
It sounds like a lot of work.
Yeah.
Right?
To map out exactly how the moon's gonna look according to its valleys and mountains.
Yeah.
That's a lot of calculating.
Absolutely. Sure. A lot of calculations go into that. And you're right. I mean, the amount of detail that we're extracting from not only the moon, but like projecting that detail onto the Earth in a detailed manner, right, and combining the effects of two to get just the most accurate path that we can kind of draw out. I think that's incredible.
Yeah,
man.
absolutely.
Seriously incredible.
Yeah.
And it really goes to show you the lengths at which NASA takes the details seriously, right?
Yeah.
So, you know, Neil deGrasse Tyson, the kind of the leading astrophysicist in terms of popularity and press, right?
Okay.
He put out a tweet a couple weeks before today, or maybe just a week ago or so, that said something to the effect of like, isn't it odd how nobody questions the validity of NASA scientists predicting the path of totality for the solar eclipse, or even that the solar eclipse is going to happen just at all.
Yeah.
And yet, in other branches of science, people seem to feel like they know better, even though they're not NASA scientists, right?
Yep.
People like to debate climate change, even though the same NASA scientists are saying, are doing this kind of detailed simulation and then experimentation to modify the simulations.
Right.
What do you make of all that?
Oh man.
No, it's a loaded question
It is
for your
a loaded
first
question.
trèSci Weekly. Sorry.
Oh man. Yeah, I think it's weird. I feel like money might play a factor. Like maybe the climate change has a lot to do with spending in certain industries. So maybe if people feel more involved and inclined to voice an opinion that's totally just made up on their own kind of thing, versus these scientists who've been studying it. But it doesn't mean that they should, because it's these guys have been studying this versus someone that hasn't been. So
Right.
just like this solar eclipse, they've been studying this. They've done a lot of research to compile the data into forming this nice map and how it's all going to be concluded. And that shouldn't be confronted with somebody that doesn't have ample research to back up a different theory, or vice versa.
Yeah. Yeah.
I think it should apply to all realms of science.
I agree. Well said. Well said.
Thank you.
Yeah, I agree. I think that it's a shame that I feel like we are lied to so often in the sense of our mainstream media and advertisements and, you know, all facets of just the everyday world that we live in, that it's a shame to me that people don't trust the word of scientific institutions.
Right.
They will for the solar eclipse, because they, on August 21st today, they will get the proof of the pudding, right? Like, either all the scientists were correct and we will experience the solar eclipse, or they were incorrect and we didn't, and then we have a problem, right?
Yeah.
So, you know, I just want to put that out there as a friendly reminder to, you know, trust in these people that dedicate their lives to these studies, because they're not lying to you.
Yeah, absolutely.
It's not a scheme. They're not.
And even
lying
if
to
you don't see that final result, like we saw the solar eclipse today, it either happened or didn't. But like climate change or other topics, you know, might be a little more of a long-term kind of change. So even though you don't see them immediately,
Right.
You gotta realize things do happen.
Exactly. Very cool. Let's check in with the chat.
Yeah, good. Right there.
Let's see. Chris Kozier says money in politics. That's actually probably Tom.
True.
Andy Dunscombe says, but honestly, climate change is a problem, a huge one that people don't want to admit is real. There's no potentially cataclysmic consequence to presenting where the moon is going to path. And he continues on in saying, so in a way, people question climate change because it has serious implications, whereas you could question the predicted path of the moon and you're just going to look like an idiot. Yeah, I think that's kind of a right in line with what I was saying about, there's going to be a payoff, right? There's going to be a very clear cut, like, yes, it happened, no, it didn't happen. Whereas the effects of something like climate change, as you were saying, take a long time to propagate, and maybe we don't quite have the predicting power to say, like, we're going to get a terrible hurricane on this date. You know,
Right.
we don't have that technical prowess yet.
Yeah.
So, but we'll see.
Yeah.
We'll see.
Good points there, though.
Moving on. Story number 3. NASA's Deep Space Climate Observatory, which is acronymed to DISCOVER, will have used its Earth Polychromatic Imaging Camera, which is abbreviated to EPIC, to measure the Earth-Sun energy system during the eclipse in an attempt to better understand the role of clouds in regulating Earth's insolation. And when I say insulation there, Kyle, I don't mean the stuff that you put up in your walls to keep your house nice and warm in the
Cozy.
wintertime. Yeah, nice and cozy.
Not that stuff.
Not that stuff.
Okay.
Insolation here really is just a fancy word for sunlight, and in particular, solar radiation. I actually hate the term insolation because it only exists since people are scared of the term radiation when talking about the sun's radiation, because they associate that with nuclear radiation in their minds, and that's like a voodoo term, right?
Don't go there.
So now we must call it insolation so that it doesn't bother anybody. But we're really talking about radiation.
Yeah. Okay.
According to NASA, quote, in this experiment, Guoyang Wen and his team will simulate the total solar eclipse in a 3D radiative transfer model, which helps scientists understand how energy is propagated on Earth. Currently, models tend to depict clouds in one dimension. In many cases, these one-dimensional calculations can create useful science models for understanding the atmosphere. Sometimes, though, a three-dimensional calculation is needed to provide more accurate results. The big difference is that 3D clouds reflect or scatter solar energy in many directions, from the top and bottom, and also out of the sides of the clouds. This 3D behavior results in different amounts of energy reaching the ground than a one-dimensional model could predict, end quote. And so I thought this was interesting in the fact that we're able to find something out, hopefully, about the Earth if we pretend that the moon passing in front of the sun during the eclipse is just a giant impermeable cloud.
Interesting.
Interesting, right?
Definitely interesting way to look at that.
So I have another video for us to check out.
All
Lots of videos this week. Lots of videos.
Kyle, if you could cue that one up.
Perfect. Nailed it. How does it feel?
Yeah, it feels good.
Yeah.
It feels good.
Yeah.
Yeah. Well, definitely a little bit different being on this side of the camera.
I'm
but
sure.
Yeah, doing all right.
All right. So this again comes to us by way of NASA Goddard's YouTube channel. This is showing us the EPIC camera, the Earth Polychromatic Imaging Camera, during the eclipse today, kind of what they expect to look at. So here we go.
Looking back at Earth from 1 million miles away, the Deep Space Climate Observatory will watch the August total solar eclipse in real time, giving scientists a unique opportunity to study our solar-powered planet. NASA's Earth Polychromatic Imaging Camera, called EPIC, will capture images of the moon's shadow passing over Earth. A team of scientists will combine data from EPIC with measurements taken on the ground to learn more about how the sun's energy is absorbed and reflected in Earth's atmosphere. Clouds affect how much of the sun's energy reaches Earth, which can be difficult to calculate without knowing how each cloud blocks, absorbs, or transmits light. Like a giant cloud, the moon blocks out the sun's energy during the solar eclipse. Because we already know the exact shape and makeup of the moon, scientists can use the natural phenomenon to develop new calculations that could improve estimates of Earth's energy system and answer questions about Earth's climate. NASA has studied the Sun and Earth relationship for more than 40 years. This year, NASA is launching 2 instruments to further study Earth's energy system.
Cool.
Yeah, I like
So, yeah, I mean, it's not just all about the sun, Kyle. We can learn more about the Earth during a solar eclipse. So I thought that was pretty interesting study that they're going to undertake there.
Yeah, absolutely.
And looking forward to seeing how the models that we currently use to account for the amount of solar energy we receive here on planet Earth, how they might be affected by changing it from a one-dimensional, maybe flat cloud to a more three-dimensional cloud model.
Yeah.
Should be interesting. Should
Definitely.
be very interesting.
Very.
All right. Moving right along. Number 4. Number 4 is kind of a cheat here, Kyle, because it's actually a pair of studies led by Amir Caspi of the Southwest Research Institute in Boulder, Colorado, will make use of NASA's 2 WB-57F research jets, which will have flown underneath the shadow of the moon, extending the time of totality to over 7 minutes and reducing the amount of atmospheric interference while imaging at 15 kilometers above the ground. So, look at you getting the image all ready to go here. So here is an image of the NASA jets that we're talking about. So we heard from Tom before, the totality, the amount of time that they were in complete darkness during the solar eclipse was about 2.5 minutes or so. What these NASA scientists planned to do, and I'm sure did this afternoon, was fly a pair of these jets in that shadow that we were seeing kind of traced out along the continental United States there, in order to get more time in totality. So they went from 2.5 minutes, bumped that baby up to like 7 minutes of totality time there.
Cool.
So, right, pretty clever.
Yeah.
This has been done before, actually. There's a really interesting documentary that I've watched some clips of from a French team that did something similar back in the 70s.
I recall that.
Yeah.
Yeah, that was cool.
Yeah.
That was really cool.
So this is kind of the updated version of this. And what they did here, Kyle, is they mounted their telescopes in the nose of the jet in order to basically keep a steady view on the sun, moon system during the eclipse, and also on the planet Mercury. And we'll get to that in just a second.
Okay.
During totality, the team will be looking for evidence of quote-unquote nano flares, extremely small flare-like waves that are theorized to propagate heat throughout the sun's corona. So again, we're talking about that wispy atmospheric layer of the sun, and they think that a bunch of these nano flares are depositing heat into the corona, right? So just not very unlike the first story that we covered already today. This would help solve the conundrum of why the solar corona is so hot, with temperatures reaching around 1,000,000 degrees Kelvin, relative to the surface of the sun, which only reaches temperatures of about 6,000 degrees Kelvin. Right, so this is a big problem. Yeah, it's a big problem in science. Why is the corona so hot? Right? It doesn't make sense. It is not close to the core of the sun anymore. Right. It is now being, kind of cast out there, blown out there in space. And space is typically pretty cold. So why would the corona be that much hotter? Why would it be hotter at all? And why would it be that extreme amount, much more hot than the surface of the sun? Doesn't make any sense.
Yeah.
So
I don't have an answer for you.
I was really hoping you were gonna
sorry.
just pull that one out of your back pocket. So they think maybe these nano flares, which we haven't seen yet, but we've got maybe some evidence of, might be the key here. So, quote, "Due to technological limitations, no one has yet directly seen nanoflares. But the high resolution and high speed images to be taken from the WB-57F jets might reveal their effects on the corona. The high definition pictures, captured 30 times per second, will be analyzed for wave motion in the corona to see if waves move towards or away from the surface of the sun and with what strengths and sizes. In this way, nanoflares may also be the missing link responsible for untangling the chaotic mess of magnetic field lines on the surface of the sun, explaining why the corona has neat loops and smooth fans of magnetic fields. The direction and nature of the waves observed will also help distinguish between competing models of coronal heating. End quote. So, pretty interesting study there to see. So even after this study is conducted, I don't believe that the scientists expect to be able to directly see what they're calling these nanoflares.
Mm-hmm.
Right? I think that it's just, they're probably too small and too bright for us to individually resolve on the camera.
Gotcha.
Right? You're the camera guy, so you this now we're right in your wheelhouse, dude. Right? So
this is my realm.
exactly. So instead, what they're going to look for is, in the corona, do we see any wave-like patterns, any wave structures, anything propagating throughout the corona, and in what direction, right? So my guess is that they expect to find some of these wave-like patterns.
Yeah.
I don't think that they would probably do this, what seems to be a pretty expensive study, if they weren't expecting to find evidence of it, right?
Yeah.
But the interesting question here is, in what direction, right? They don't know if it's going to propagate outward from the surface of the sun out of the corona, or somehow inward from like the outer reaches of the corona back in towards the sun.
Yeah.
Interesting.
Yeah, that is interesting.
I don't really see how the mode of heat transfer could really benefit from coming from the outer corona back inward.
Right.
But then again, I'm not a solar astrophysicist
Yeah.
with a PhD, so of course I don't understand how that would work.
Yeah, neither am I.
Yeah, so we'll see, right?
Yeah.
That's the goal, is to learn what we can from these studies, right?
Do you have a prediction one way or the other?
My prediction is that they will find evidence of the waves. It will account for some heat transfer, but probably it will still be a mystery as to why the corona gets so hot, right?
Yeah.
I think, that's just my,
Yeah.
without any real hand in the cookie jar of like,
For sure.
yeah, that's
Yeah.
just my take on it.
Okay.
In addition, right, I told you this was a twofer, right? This is a twofer special here. Twofer coronas. In addition, Caspi's team will also be imaging the planet Mercury in the half hour just before and just after totality. We've got a little image of Mercury to bring up as well. Do we have somewhere in there?
Yeah, we'll get around to it.
Quote, "These images taken in the infrared will be the first attempt to map the variation of temperature across the surface of the planet. Mercury rotates much slower than Earth. One mercurial day is approximately 59 Earth days. So the night side cools to a few hundred degrees below zero, while the day side bakes at a toasty 800 degrees Fahrenheit. The images will show how quickly the surface cools, allowing scientists to know what the soil is made of and how dense it is. These results will give scientists insight into how Mercury and other rocky planets may have formed," end quote. And image credit goes to Amir Caspi for the jet image that we did before. And for this one, this is NASA, Johns Hopkins University of Applied Physics Laboratory, and the Carnegie Institution of Washington. I believe that this is a study used from the Mercury Messenger spacecraft. That was one of our first imaging. It was our first spacecraft to get a full kind of image of the entire surface topography of Mercury.
Okay.
And now we're looking to study even further what's going on Mercury as far as heat transfer from the daytime to the nighttime. because it's real hot during the day and then real cold at night.
Yeah.
So they want to see if they can figure out what that soil is made of. And I just think that's a sneaky way to study Mercury, right?
Yeah.
It's like let's wait for the solar eclipse, because it's hard to look at Mercury even, as somebody that owns a couple telescopes.
Yeah.
Mercury is always so close to the sun, it's the innermost planet, that you have to wait for the sun to set, and then Mercury trails very close behind it, so it's always close to the horizon, and it makes it difficult to image, because then it sets really quickly afterwards. Or you have to wait for it to rise prior to the sunrise at like 4 a.m. sometimes, and then the sun comes up and drowns out Mercury. You can't see it anymore.
Yeah.
So
very short time frame that you can actually.
Very short time frame. So I wonder if Tom and Chrissy, if one of those stars that they thought they were looking at, maybe it was Mercury.
That would have been cool.
Probably.
Wow.
Probably.
Pretty sweet.
How do you feel about the planet Mercury?
I like it.
What's your favorite planet?
Oof, that's a good question. That's a good question. I think after we look through the telescope, it might be Saturn, man.
Yeah.
I really was digging those rings that we saw in that telescope that we took out. So that was something else.
Yeah.
Yeah, real cool.
Sweet.
Yeah. Hate to just be a bandwagoner like that, but gotta do it.
Hey man, I hear you. No, Saturn is beautiful.
Yeah.
I'm sure we'll have some interesting Saturn news coming soon with the Cassini spacecraft kind of at its finale point here now. Let's check in with the chat. How are we doing? So, Kristen Cozier, which is really Tom K, says, clouds are interesting because they block insolation from reaching Earth, as well as absorbing outgoing infrared radiation from the Earth to keep heat in. So that's jumping back to one of our prior stories. Yeah, absolutely. And then looks like Nancy Kalita is having a little bit of internet stutter there.
Ouch.
So no problem. It's okay. You can always watch the replay of trèSci Weekly when your internet is spiked up and ready to go.
Yep.
We're always here for you.
Always here.
Always here for you. All right, let's close it out here, Kyle. Number 5, the last one on the docket that I'm looking forward to seeing the results of, is actually not a NASA-funded experiment. It's a citizen science experiment.
Cool.
It's called the Citizen CATE experiment, and CATE stands for Continental America Telescopic Eclipse. Right? So what is it? Quote, the Citizen CATE experiment aims to capture images of the inner solar corona, again, that layer, that outermost atmosphere of the sun, using a network of more than 60 telescopes operated by citizen scientists, high school groups, and universities. CATE is currently a joint project involving volunteers from more than 20 high schools, 20 universities, informal education groups, astronomy clubs across the country, 5 national science research labs, and 5 corporate sponsors. So there's a lot of people that have some stake in this,
Yeah,
if you will.
sounds like it.
The goal of CATE is to produce a scientifically unique data set, high-resolution, rapid cadence white light images of the inner corona for 90 minutes, right? Now, how the heck are they going to do that, Kyle? The total solar eclipse only lasts for 2.5 minutes during totality. How are we going to get 90 minutes of corona activity? Well,
It almost like everyone would have to have a camera or something.
it would almost be like
Right.
everyone would have to have a camera and a telescope.
How do we do that these days, huh?
That's just what we did, right? They got all these people to volunteer their efforts in a line, in a path along that totality line. They had cameras set up, and they used, I don't know exactly what telescope or what camera, but they used a universal instrumentation. Right? Everybody had the same equipment,
Okay.
and they all captured totality from their station along the country.
Wow.
And now what they're going to do, Kyle, is they're going to stitch all of that footage together and create a 90-minute time lapse of the corona as it changes during
That's cool.
during the whole thing.
That's really cool.
Really cool.
Yeah.
So I can't wait for this video to become public domain because you know, I'm going to spend the whole 90 minutes with my popcorn and my soda and checking it out on the TV.
Yeah.
I'm super excited for it.
I like that they reached out to the community, because one man alone, one organization can't do it by themselves.
No.
You need the masses.
And not only can one man not do it, or one woman, as we might say, but NASA can't do it with a team of, you know, jet pilots, right? They're only going to get 7 minutes of totality in the shadow. So yeah, you're right. By everybody coming together in the community, men, women, children, you know, scientists, enthusiasts, amateurs, students, everybody, come together. Let's build this awesome video and see what we can learn from it.
Yeah.
I think that's awesome.
Me too, man. Me too.
Really cool.
Yeah.
To continue, during their window of totality, magnetograms from each site will trace polar plumes that appeared above the northern and southern solar coronal holes during previous eclipses while the sun was relatively quiet. And I have a picture here of what a solar hole or a coronal hole might look like. So let me bring that up on my computer here too. Close out of it for some dumb reason. So this is an image from SDO, the Solar Dynamics Observatory. This is another space-based spacecraft that looks at the sun at all times. And this, I think, is looking in another X-ray filter. So again, we're seeing a dark patch here that's just indicating an area of what we call quiescence, or like not a lot of activity.
Okay.
Right. So supposedly there are coronal holes typically at the northern part of the sun and the southern part of the sun where some of these polar plumes originate from, and that's what they are interested in kind of seeing with this 90-minute video. Continuing on from what they say on the website, combining data from all the sites should give scientists a higher resolution map of the plumes' location. Scientists also hope to measure movement within the plumes using the extended observation session. During previous eclipse, scientists noticed changes in the corona above the sun's southern pole, but they could not measure any radial movement because of limited data from 2 images. The images from all 68 citizen CATE sites should increase understanding of the corona's internal movements, end quote. So, pretty awesome.
Really awesome.
Yeah, really looking forward to like I said, watching that and seeing what we can draw from it, because this is a unique opportunity, even just in general, right? It's not very often that a solar eclipse traverses this much landfall where people, you know, live. So definitely awesome.
Did you look into what you need to be a part of that if we were in the totality range?
You know, I did look into it, but I did not plan to partake, just because of knowing that I was, you know, financially constrained from going down to the totality line anyway. But
Plus we had the great program also.
Exactly, we had the library program. We had you know, lots of other things going on.
Oh yeah.
But certainly that is something that I would have liked to have been a part of.
Yeah,
for sure.
Yeah, it sounds fun. We should keep up if they ever do something like this again.
Absolutely, yeah. Definitely.
Like what Tom said here, maybe in the future one day, instead of only jury duty, you will have citizen science duty.
That would be amazing.
That would be so cool.
Yeah.
And for a purpose.
Yeah,
actually,
great purpose.
For a purpose, yeah.
Yeah.
Not just wasting your day away.
I would love to hear people complain about it, though. It's like the way that they complain about jury duty. Oh man, I have to go get my telescope out and look at the solar eclipse for 6 hours or whatever.
This is terrible.
Yeah, this is terrible. I'm just gonna pretend I'm sick. Andy says it's like everyone putting one piece of a big jigsaw puzzle together. Adds to the feeling of the eclipse as a uniting, all-inclusive event. So
I like that.
I like that as well.
Me too. Yeah. Makes you feel like you're a part of something too.
Yeah,
Totally.
part of something grander for
Yeah.
sure. All right, Kyle. Thank you so much for joining me on trèSci Weekly this week. I want to close out this week's episode with a map. And the map is actually of the next solar eclipse, April 2024. We will see it crossing it'll go across the United States in kind of the opposite directions. It'll still go west to east, but it'll actually go from the southwest, actually originating in Mexico. It'll go up through Texas, and it'll travel northeastward, passing right through New York State, and not too far into the distant future, right? 7 years from now, we will get another opportunity to check out a total solar eclipse. So, if you didn't get to see it this time around, have no fear. It's only 7 years away for the next one to cross our paths here at home. And you know that I'm going to be looking forward to it.
Yeah, we got to be there.
We got to be there.
Got to be there.
trèSci, mark my words, trèSci will be in the path of totality. All of us together
All three.
this time, holding hands.
Holding hands.
Yeah.
Singing songs.
Absolutely. So guys, thank you for checking this episode out. I hope you enjoyed the change of format a little bit this week. Kyle, thank you so much for joining me on this week's episode.
Thank you for having me.
Yeah, you did awesome, man. You're a really great co-host, not
you.
just a great cameraman and a great producer of the show, but also a great co-host. So thank you very much for being on the show with me today.
Thank you. Appreciate it.
And we will catch all of you guys next week for more science news on trèSci Weekly.
That's right.
Signing off. Catch you.